Okay, greetings students. Today we're going to talk about 3.2c, solving polynomial equations. The first thing you'll do to solve a polynomial equation, set it equal to 0. The second thing you'll do is attempt to factor it. What I mean by attempt is attempt to find a common factor or attempt to factor it using one of the methods we discussed in the past or the ones we're testing today. And then after you factor it, you can use the zero product property to find the roots. So the two new formulas for today: sum of cubes, difference of cubes. These are third powers, so these are a to the third plus b to the third, a to the third minus b to the third. So the two differences in the formulas are the a plus b cubed uses a plus here, the a minus uses a minus here. And kind of counterintuitively, the a plus uses a minus here, and the a minus uses a plus here. Now some of you are a little bit worried about remembering these formulas. What I'm going to tell you right now is that's kind of why we usually would give a note card on the test for these two formulas. I don't require them memorized. You are allowed to use your notes pretty much on the test because we're doing this online. So that should not be an issue to remember the formulas or be able to have access to the formulas for these. The issue should be, how do I use the formulas? So here's an example. So what I like to do here is I like to identify the values of a and b. Well, a is easy because it's x. Now b is not 8. b is the cube root of 8 because b cubed should be 8. I could say a cubed equals x cubed if I wanted to. So maybe that's probably a better analogy here. A cubed is x cubed, therefore a is x, because the cube root of x is x cubed is x. And then b cubed is 8. So what would b be on this question? What is the cube root of 8, or what to the third power equals 8? 2. Now how can I find that using a calculator? Or how can I find that with logic? Well, so what you're going to do is you're going to think about, well, what is 2 times 2 times 2? 2 times 2 is 4, times 2 is 8. Cube root of 8 is 2. Or 3 times 3 times 3. 3 times 3 is 9, times another 3 is 27. 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. What I'm doing here is doing the cube root of 64 is 4, the cube root of 27 is 3, and the cube root of 8 is 2. So that's kind of how I think about these things when I'm thinking about these things. If you want to use a calculator, again, I recommend, most likely most of you are not going to have a TI version of a calculator, so I would recommend a Desmos variety of a calculator. There is no cube root symbol on most calculators. You can accomplish a cube root various different ways, but understand there's no cube root symbol on most calculators, one symbol on the calculator. So if I want to do, for example, the cube root of 8, I'm going to do 8. I want to do an exponent here, so I want to do not a squared exponent, not a b exponent, I just want to do a normal exponent. So I'm going to do, I think I'll do this one. Over here, there should be a power symbol somewhere. Well, there's a cube, there's a root symbol there. Not a power symbol. I know where this is at on the, whatchamacallit, on the computer version of this. Go ahead and practice on the non-computer version. None of those, I know that. So it would be here if it was here. Alright, I guess we're going to use the actual symbol for cube root. So I cannot find the symbol for it. Alright, so there it is. Cube root of 8 is 2. How did I do that? So again, what I did is I went to the menu here, and I found this little guy. Put the 3 in the top, put the 8 inside. that is the cube root of 8. If I wanted to do another number like 27, there's cube root of 27 is 3. There's a way to do this with exponents too that I was looking for out here, but I couldn't find the exponent symbol. It's on the computer one. It's an a to the x symbol or a b to the x symbol when you look for it. Anyhow, so a is x and b is 2. So this is going to be a is x plus b is 2, 2. The quantity x plus 2 times the quantity x squared minus a times b, x times 2, or 2x. So I wrote the formula the way it's always written, but we actually put b times a here because b is always a, or I shouldn't say b is always a constant, it's a constant in most classes. So in reality we usually put b first there. We usually put minus b times a, but the formula says a times b. Alphabetical, like any other formula. Oh, there's no square symbol at the end. There we go. Now, this part inside, right here, this part inside is not going to factor for the majority of polynomials. There might be one that it does happen to factor with, but it is not going to factor for the majority of them. You could attempt to factor it, you know what I'm saying, but it's not going to factor. Alright, difference of cubes, a is equal to x here, and then b is equal to 3. Where did I get the 3 here? Well, because 3 times 3 is 9, times 3 is 27, or I could say the cube root of 27 is 3 like we just discussed a second ago. Now, I didn't use negative 3 here because the negative is already accounted for in the formula and in the difference of cubes here at the above. So you don't have to say b is negative 3. So you're not going to do a minus negative 3 and make it a plus 3 here, because then it just becomes the sum of cubes formula again. Alright. If you wanted to use the sum of cubes, you could use the sum of cubes formula for this and just put a cubed plus the opposite of b cubed. So in other words, you could just make this a negative and then it would become what you wanted it to become. So we're going to have x minus 3 here to start this off. And it's going to be x squared minus, plus 3x. And again, we use b times a here because b is a constant. And it's going to be a constant for your questions, so that's kind of what we're doing here. And then plus 9 at the end. And there we go, that's factored. So what does this mean for you? Well, these are the factored forms of these, and you could find a 0 using the factored forms of these. A 0 again is when the equation is equal to 0, or when the graph of our original x cubed plus 8 crosses the x-axis. So we could say literally on this one that it crosses at negative 2, and on this one that it crosses at positive 3. And then the other crossings would be given by these two quadratics, which we could use the quadratic formula for. Alright, we'll get to that in a second. But let's do some more techniques here that could help you out. So some other things that can help you out on this work today is if they have a common variable. For example, all three of these terms have an x squared. Pull that into the front. And also if they all divide by a common number. For example, 18, 27, 45, they all divide by 9. Pull that in the front. And then we'll make the quadratic, we'll make the expression or equation, in this case an expression, more manageable. So if I pull a 9 from an 18, it becomes a 2. If I take 2 away from the power x to the 4th, it becomes x squared. If I pull a 9 from a 27, it becomes a minus 3. Take 2 away from the power of x cubed and becomes x. Pull a 9 from a 45, it becomes a 5. And then take 2 away from the power x squared and it's gone. So there we go. You can see that what happened on this one is I made this into a quadratic now, and now I could attempt to factor this, factor the 10 to make a 3, which you could do with a 5 and a 2. If I could actually do 5 minus 2, which I can't, because that 5 is positive. But if I could do 5 and a 2. But anyway, so you can see, you could factor this now using a quadratic factoring, this inner portion. And it's easier factoring. Alright, and then like we talked about in the previous examples, when you're doing quadratic factors, or quadratic trinomials, this one is similar to this one above, but this one actually does factor. So you take a times c, so it says find the factors of a times c and the sum of b. So a times c again on the top, that's 24, negative, 6 times 4. Our goal number is negative 5, and we can accomplish that goal by doing a negative 8 and a positive 3. Now those aren't our exact factors here because again we have an a term. So we're going to divide both of those factors by 6 to get our actual factors. So negative 8 divided by 6, and that reduces, doesn't divide evenly, into negative 4/3. Which that tells me one of my factors is 3x minus 4. And again, this is just the way I factor. I mean, there's other ways to factor. And again, that's a 3x minus 4 because that's a 3 on the bottom and a 4 on the top. I didn't use 6 and 8 because 6 and 8 reduces. It's very important to reduce if you're going to use this method. And then the 3 divided by 6 makes it half. Positive 1 over 2, not negative. So that tells me other factors of 2x plus 1. So there I've accomplished factoring that with the a times c method, or you could say the cross method. And you can check your work. 6x squared, there it is. Negative 4, there it is. Then you have here 3x minus 8x, negative 5x, there it is. So we got our factors done properly there. Alright, moving along. Next time we got perfect square trinomials. So again, if the b term in the middle here is the square root of the c term, then you have a perfect square. So you can see here that 16 is the square root of 64. This tells me that this is x plus 8 quantity squared, which you can write as two separate terms or one single term. X plus 8 with the squared symbol on the outside of the parenthesis. And then here again, this is the same thing. This is a minus because 16 is the square root of 64. We got x minus 8 times x minus 8. Not squared, just regular. Or we just do x minus 8 quantity squared for that one as well. And that would be functional. It would be perfectly fine. Okay, on the back here, difference of squares. This is a squared minus b squared. So this is not a good example of a squared minus b squared because look, it's not perfect roots. This was supposed to be a 36 at the end. It got mixed up. So if these are both perfect squares, it's supposed to be 36. So this was 2x squared and this is 6 squared. Then you can factor with 2x plus 6, 2x minus 6. Well, yeah, that only works if they're perfect squares. I guess I could have used the square root of 3 here. 2x plus the square root of 3 and 2x minus the square root of 3. If I wanted to use the difference of squares formula here to factor that, that would be functional actually. Factor by groups. So if you have a cubic with groups, first group, second group, take the first group, pull out the items in common. So these both have an x squared that they both have in common, times by x minus 4. These both divide by 9, minus 9 times by x minus 4. The important thing with this method is that these two items match. That tells you that you factored appropriately. They both are x minus 4 there. So those are both x minus 4. And my other factor is these two, x squared minus 9. Now that's actually a difference of squares, so I could actually go further here and put this as x plus 3x minus 3, but I ran out of space. So I'm going to leave it there. And then the sum and difference of cubes that we just talked about. So here on this particular one, a is equal to 8x. 8, no. That's the square root of 64. 4x. And b is equal to 1. So again, we're going back to our new formula today on the front, this one right here, sum of cubes. A plus b, 4x plus 1, times the quantity a squared would be 16x squared, minus 4x plus 1. Again, it's kind of counterintuitive that there's a minus sign there in the formula, but there is a minus sign there in the a plus b cubed, a squared plus b cubed formula. And similarly with the difference of cubes, we have the same thing. A is equal to 4x and b is equal to 1. Again, we don't use negative 1 here because the formula accommodates for the negative sign when you're using the difference of cubes. So the differences in the formula is there's going to be, instead of a plus, there's going to be minus 1. And then there's going to be a plus in the middle of this. And again, it's important you have a squared plus bx plus b squared here. B squared happens to be a 1. That's why that's just a 1 there, but there's the two new ones today. And again, I could use the quadratic formula to find the two zeros for these. And then this, I can get these zeros from the, just setting it equal to 0, 1/4, and then negative 1/4 on that one. Alright, so let's talk about real and imaginary zeros. What you're going to do is going to set things equal to 0 inside the parentheses on each of these. Now, they have to be inside the parentheses to set them equal to 0. So, example 1 is set up for you. So, x squared minus 1, sorry, equals 0. Therefore, x squared is 1. So, x is equal to the square root of 1, positive and negative. So, x is equal to a positive 1 and a negative 1. Those are two real zeros. 1 comma 0 and negative 1 comma 0. The second one here yields imaginary zeros. So if I see here x squared plus 4 equals 0, x squared equals negative 4, that's not a real root. That's an imaginary root. So these two zeros are real from the first half of the equation, x squared minus 1 equals 0. These are complex zeros. X is equal to 2y and negative 2y. So those are my two imaginary zeros. There are 4 zeros for this equation because we got x squared, we got x squared, we got 2x squareds. Oh, we got x to the 4th. X squared times x squared is x to the 4th. There's 2 real zeros, and then there's 2 imaginary zeros. So then the 2 imaginary zeros are 2i and negative 2i, and those would be on the complex plane. So I could write those as 2i comma 0, and then negative 2i comma 0. These are the complex zeros. Okay, this one is an x to the 5th equation. It's x to the 5th. I need to set this equal to 0 before I can do anything else with it. So I'll move the x to the 4th and the x to the cubed over to the other side. So this will become a negative 5x to the 4th next to the x to the 5th. So in other words, x to the 5th minus 5x to the 4th, and this will become a positive 2x cubed next to the x to the 4x cubed. Now those are actually going to combine to make a 6x cubed, because those have the same power, plus 6x cubed. So what I'm seeing here is, so now it's equal to 0. What I'm seeing here is this is a trinomial. So what I'm thinking of is trinomial factoring methods. So the types of trinomial factoring methods, factor by grouping works with 4 terms. Difference in sum of cubes will only work with 2 terms. Difference of squared works with 2 terms. Perfect squares, so I'm thinking maybe it's this, perfect squares, trinomials, quadratic trinomials, and then factoring out a common greatest common factor. So I'm thinking of these three options. So I'm going to go through them one at a time. Factoring out a greatest common factor. Do these have a common factor? They all have an x cubed in them. This is x to the 5th, which is x cubed times x squared. This one's x to the 4th, which is x cubed times x. So I'm going to start off with the x cubed in the front here. X cubed times x squared is x to the 5th. X cubed times by x is x to the 4th. So that 5x to the 4th becomes just a 5x. And x cubed times by 1 is x cubed. So this is going to become a 6. And now, you can see here I've got one of my zeros. X cubed equals 0. Unfortunately, that only yields 1 0. X is 0. So there's a real 0. Real at 0, 0. Now the x squared, this part here, I'm going to attempt to factor this either with the quadratic formula, the sum, or the perfect squares. These two options, quadratic trinomials or the perfect square trinomials. I've noticed here that this 6 can be divided into a 3 and a 2 to make a 5 if they're both negative, and it will still multiply to a positive 6. I'm not going to use 6 and 1 because the 6 is positive. If the 6 was negative, I could use negative 6 and positive 1 as my factors. So my other two factors here are going to be x plus 1 equals 0, which is x equals negative 1. So negative 1, 0. And then my final factor is x minus 6 equals 0. So x is equal to 6. So that's my final 0. 6, 0. Alright, so some of you, this is going way over your heads. You're thinking this is way over what I think I can do, what I think is possible. So we're going to talk about that right now just a little bit. I'm hoping to find the power key on my calculator. I still can't figure it out. Okay, so I figured out the power key on my calculators. So some of you, you're like, this is way over my head. So what you can do is on your calculator, type the equation in. So to do that, let's talk about the first one, x squared minus 1 times the quantity x squared plus 4. What did I just do? I graphed this on my calculator in Desmos, and now what I can do is I can find, this is the vertex. It's not really important in this case because I'm asking you to graph it, but these two values, negative 1, 0 and positive 1, 0, are my real zeros. Those are my real zeros. So you can get half of the answers here with the calculator, the real zeros. The imaginary zeros the calculator is not going to give you, because it's just not going to give you those. The Desmos calculators. There is a type of graphing calculator that does do those type, but not this type. Alright, so this other one, to get the x to the 5th on this, the way I've figured it out is type in x squared, but just go up, click on above, and change the 5 and change the squared into a 5. So that's now x to the 5th. Minus 5x. Again, I'm going to use the squared key, but I'm going to go and, tap it. Make it x to the 4th. And then plus 6x cubed. And again, the nice thing about Desmos is it's nicer than our graphing calculators even at school is it tells you the zeros real easily. 0, 0, 2, 0. So I've made a mistake somewhere. I don't know where I made a mistake. Oh, I talked about this being 3 and 2, then I used 6 and 1. Dumb me. That's dumb in me. And then 3, 0. Yeah, I talked about this being 3 and 2, and then I used a 6 and a 1. That was a dumb mistake by me. Sorry, guys. So positive 3 and positive 2. It is actually always useful, when I was taught this in school, in high school and in college, it is always useful actually to type these in a calculator and to verify your zeros. If you have a calculator laying around, it's always useful to type them in. 0, 0, 2, 0, and 3, 0 are my 3 zeros. And so even if I do these by hand, you'll see me typing them in the calculator. Some of you are wondering why it's x to the 5th and it only has 3 zeros. That's because this x cubed only has 1 0 at 0. So a 5th power would have 5 zeros if I hadn't reduced 2 of them out with the x cubed here being 0, and that only having one possible 0, which is 0. So that's why it only has the amount of zeros it has. Okay, so moving along to the next page, x to the 4th is 16. Find the real or imaginary solution for each equation. So what I can do here is I could say x to the 4th is 16. I could factor this out into a pair of x squared equal to 16s. Or I could say x to the 4th minus 16 equals 0. Maybe I'll write it like that. I'll set it equal to 0. And this is a perfect square binomial. This is x squared times x squared, and this is 4 times 4. So I would say here that x squared minus 4 times x squared plus 4 equals 0. And then I can solve each of these. So x squared minus 4 equals 0, therefore x squared is 4. So x would be equal to 2 or negative 2. There's 2 of my solutions. Those are real. So those are actually real solutions. Now we're talking about solutions here, not zeros this time, so I'm just going to use x equals. So on the other page I was talking about zeros. Sorry, I was on the back of that one. Here I was talking about zeros, that's why I used y equals 0. But here I'm talking about the solutions. What was I talking about solutions there too? I was talking about solutions here too, so I could just use x equals actually if I wanted. X equals 3, 0, and then 0. Or 3, 2, and 0, and then x equals 1, negative 1, 2y, negative 2y. So this one is x squared plus 4 equals 0. So this again is our complex solutions. X squared is negative 4. So these are going to be my two complex. X is equal to 2y or negative 2y. And again, if I'm looking at this on the graph, in the graphing sense, I could type this in the grapher into the Desmos grapher. And what I would see is it's going to cross the x-axis twice. So x to the 4th minus 16. So it's not going to give me the complex solutions here. It'll give me the two real solutions, negative 2, 0 and positive 2, 0. These two solutions right here. The complex solutions, the calculator will not give you. So you'll get half of the answer from a calculator here if you want to use a calculator to help you out. Alright, this one, move the x squared and the 8x over. X cubed minus plus 2x squared minus 8x equals 0. Notice here these all have an x in common, so I'll pull that x in the front. X times the quantity x squared plus 2x minus 8 equals 0. So that tells me one of my real solutions is x is equal to 0. Right here, x is 0. Then the other one I'm going to get by trying to factor this. So for an 8 to make a 2, I'm going to have to use 4 and 2. So I'm going to use x plus 4 and x minus 2. So those are my other two zeros. X plus 4 equals 0 and x minus 2 equals 0. So I would have x equals 0, negative 4, or positive 2. Are my three, in this case they're all real solutions. Again, it's pretty quick to check. I was going to say it's very easy. It's not very easy because if it was easy everybody could do it. But it's pretty quick to check your zeros on a calculator, any type of graphing calculator. X cubed plus 2x squared minus 8x. So I can just use the original function there at the very top. And I can verify here's a 0, negative 4. Here's another one, 0. Here's a third one, at 2. Just using my Desmos calculator. Again, on my phone or on the computer, either one. Computer works a little better sometimes because it has all the keys there for you. Alright, 0. So I have to actually multiply everything in first. X cubed plus 8x equals 8x plus 1. Then we move everything over to the left. So I take the 8x from the 8x, actually makes nothing. So it's going to be x cubed minus 1 equals 0. So this is actually a difference of cubes. So I'll use the difference of cubes formula with a equal to x and b equal to 1. x minus 1 times the quantity x squared plus x plus 1. So here's a real 0. X minus 1 equals 0. X is equal to 1. That's my first real 0. Now this part here, x squared plus x plus 1, that does not factor. So does this in fact have real zeros? I could use the quadratic formula, or like I said before, if I want to see if those are real zeros, it's very quick on a graphing calculator to see if those are actually real zeros, and just by typing it in. So I have here x cubed, minus 1. And you can see here it's only got one real 0, at x equals 1. That tells me these other zeros are imaginary, complex zeros. How do I find them? Well, the most efficient way to find those would be to do the quadratic formula, because that will give you all of the zeros of a quadratic. So you may have to use the quadratic formula on some of these questions to find the complex zeros to finish the question. So for the other two zeros, I'm going to do x is equal to opposite b plus and minus the square root b squared minus 4 ac all over 2a. This will give me my other two zeros, my imaginary zeros or complex zeros. So negative 1 plus and minus the square root. You can see this square root is negative 3, 1 minus 4, all over 2. So there's my real 0, and there's my complex. The complex zeros should come in pairs. There should be 2, 4, 6, 8. There should never be a single complex zero. There should only ever be pairs of them, because it's a plus and minus item going on. They always come together like that. So negative 1 plus and minus the square root of negative 3, which I could write that as I root 3 if I was to be actually particularly accurate. The square root of negative 3 is I root 3. Again, I use the quadratic form here. X is equal to opposite b plus and minus the square root b squared minus 4ac all over 2a. Quadratic formula. And if you don't remember the quadratic formula, again, you'll be able to use your notes, and so that you can do that. Okay, so finding real roots by graphing, I would recommend method 2. So I'm going to ignore method 1 because that one's just extra work. Method 2, rewrite the equation. So in other words, get everything on the left and then graph it. This is what I was just showing you on Desmos. So like for this guy right here, when it says to solve that, I don't know if this is an accurate graph of that. I think it is, if I remember right from last year. So I would type this in the calculator. So it's x cubed. It's plus x squared. And then it's going to be squared. Minus x plus 1. So there it is graphed. I just put everything on the left, and it's equal to 0. And you can see here, that is my real solution right there. Negative 1.839. Looks like it is an accurate graph, actually. So there is my real 0, where it crosses the x-axis. And then it's going to have two complex zeros. I'm not actually asking to find the complex zeros here on this one. Just the real zeros. In this case, the real 0, 1, 0. So that's what that's talking about. And again, I wouldn't recommend the first method here, the intersection method. That's just extra work usually. And it's usually easier to do method 2, the 0 feature. Which this is a 0 feature on Desmos, is just where it crosses. Alright, let's talk about example 4 and example 5. These are ACT questions. Find 3 consecutive integers whose product is 480 more than their sum. Oh my gosh. Whose product is 480 more than their sum. I did not practice this before I came into this question, so I might not be able to do this one. So we're going to say our first integer is x. If they're consecutive, it means there's one above. They're adding 1. So my first integer is x. My second integer is x plus 1. And my third is x plus 2. Consecutive means you add one more to the number. So for example, 3, 4, and 5 are consecutive. 4, 5, and 6 is consecutive. 5, 6, and 7 is consecutive. Alright, so it says their product, when you multiply them, so we're going to actually end up multiplying these. X times x plus 1 times x plus 2 is 480 more than their sum. So their product, if I add 480 to it, I get their sum. Which their sum is, of course, x plus 1 plus x plus 2. So what I'm actually asking you to do is to solve this equation. And to solve this equation, I'm trying to think if there's an easier way other than multiplying the left, and I don't think there is. We're going to multiply out on the left here. So we're going to multiply this x into the inside parentheses. X squared plus x times the quantity x plus 2 plus 480. We're going to combine everything on the right. X plus x plus x is 3x. 1 plus 2 is 3. And then we're going to multiply this out as well. X times x squared is x cubed. X squared times 2 is 2x squared. X times x is single x squared. X times 2 is 2x plus 480 equals 3x plus 3. I'm going to take the 3x from the 2x. I'm going to combine these x squareds. I'm going to take the 3 from the 480. So x cubed plus 3x squared. 3x taken away from 2x is minus x, and then 3 from 480 is plus 477 equal to 0. And so now I can solve this for its real 0. I'm looking for a real 0 here. It does have 3 zeros. I just need a real 0, and if there happens to be more than one, well, then that means there's more than one answer. So what I'm going to do now is I'm just going to use Desmos, and I'm going to type this in. I got the x cubed already typed in, so I'm just going to change that to a 3x squared. I got a minus x, and I got a plus 477. And then I'm going to find it 0, and it looks like I've already found it right there, -9. I could zoom out and see if it has more. It most likely does not. You can see here it just keeps going up, so it does not have more than 1 0. Or a real 0, I should say. It does have more than 1 0, it's not more than 1 0. So -9 is my answer. Is my answer that I'm wanting to use. -9, -8, and -7. And if I wanted to check my work, I could add those three together, and then I could multiply the 3 together and make sure that the product is 480 more than their sum. That's what I'm trying to do here. That their product is 480 more than their sum. Anyways, so yeah, we could check the work here. Why not? So if I took -9 plus -8 plus -7, I get -24. If I multiply them, -9 times -8 times -7. You can see here it's -504. Oh, and I did this backwards. I got the product 480 less than their sum. So I'll just change that to a less at the top. I put the 480 on the wrong side when I started the equation. So I'll change that to less than their sum because I put the 480 on the wrong side. I should have put the 480 here with the x plus 2. Should have had that as a -43. But I'll just change that to a less at the top so I don't have to go through and do the whole work, the equation again. Alrighty. Another example of the same stuff. Let's see if this time I get the equation exactly perfectly right, or if I make a mistake like last time and have to change the question at the end. The Perez twins were born 2 years after their older sister, so they're twins, there's 2 of them. This year, the product of the three siblings' age, so the Perez twins are the same age. So we're going to say the Perez twins are X years old. There's two of them. And then their sister, older sister, that there is kind of a weird wording. The Perez twins were born 2 years after their older sister. That's the correct wording, but it means that their older sister is 2 years older. Alright, so the older sister is X plus 2. The wording there just kind of bothers me sometimes, like, I don't know why. This year, the product of the three siblings' age, so if I take these three and multiply together, X times by X times by X plus 2 is 4,558 more than the sum of their ages. So this time I'll set it up properly. If I add the ages together, X plus X plus X plus 2, and then add another 4,558 to that, I can get the same number. So there's my setup. So I'll multiply everything out on the left here. X times X is X cubed. X times 2 is 2X squared. And then if I take X plus X plus X, I get X cubed. X cubed, 3X, not X cubed. Then 2 plus 4,558 is 4,560. Move everything on the left. X cubed plus 2X squared minus 3X minus 4,560 equals 0. And then we can use a calculator to assist us here in finding the actual real 0. Because that's all we really care about is the real 0. So I'll change that 3X squared into a 2X squared, change that minus X into a minus 3X, and the 477 I used here will be a minus 4560. And you can see here there's a number right there, 16. Number right there. Oh, you can't see what I typed in. That's what I typed in. I just typed in this again in the Desmos. 16. So X is 16. So it seems to me like the twins are 16 and the sister is 18. So I could check my work, and if again this was an SAT question or ACT question, you would definitely want to check your work so you can get the points for it. So you can make sure you get the points. If the twins are 16, it says here, the product of the three siblings' ages, the twins are 16, the sister is going to be 18. So the product of their ages is going to be 16 by 16 by 18. There's the product of the three ages. 4608. And it should be 4,558 more than the sum of their ages. So their sum of their ages, 16 plus 18, is 50. So if I take 4608 and take away 50, I get 4558, which is what we said in the question it was supposed to be. So that is an easy way. There's what you do to check your work on this question. Anyway, sorry this was a longer one, but your work is in the notebook. Good luck on this one, guys. And again, ask questions in class. Thank you.